Hello and welcome to the Space for Kentucky meeting. I am Izzy House, and I know a few of you, and I am an author of 2 now space books, a podcast host, and a space nerd. And Space for Kentucky Roundtable is a place where we can all come together, our businesses, enthusiasts, and discuss and share insights about the space industry. It provides opportunities for individuals and companies to come together so that we can make the space economy healthy and grow it. Each meeting, we have a theme, and I bring speakers together so that we have a sneak peek at what all the different industries do. And there's a small list of industries on spaceforkentucky.com, plus recordings from previous meetings. So I encourage everyone to sign up to receive information about the upcoming meetings and to receive notification when the recordings have posted. The theme for tonight is Industries for the Moon, Going Back to Stay. Tonight we have 5 speakers. First, we will start off by looking at the moon with Kirby Runyon, which is a planetary geologist and a CEO of Planetary. Then we will look at researching the moon with Melissa Roth, and she's a researcher and co-owner of Off-World Research. Then we will land on the moon with Chris Colbert from NASA's Commercial Lunar Payload Services, or the CLPS program. And then we will plan on the moon bathe with Britt Duffy Atkins she is a space urban planner, podcast host, and CEO of Celestial Citizen. And finally, we will be building a moon base with Sam Simmons, space architect and CEO of Exploration Architecture Corporation. And we'll have 1 or 2 questions after each speaker, and then there will be a question and answer portion at the end. So let's launch this meeting. We will begin by looking at the moon. And Dr. Kirby Runyon was a speaker at the Space Tourism Conference this past April. This evening's theme is a result of the chat that him and I had right before we did the event. And he was working on mapping the moon. And I got to tell you, I was riveted. It was so interesting. And that night, this theme was born. Dr. Kirby Runyon loves experimental space exploration and works as a NASA-funded planetary geologist. He is a space tour guide and an inspirational speaker. Kirby has been a guest on my podcast for the Space Tourism series, and he coaches flyers in weightlessness with the Zero Gravity Corporation. He takes commercial future astronauts through educational geology hikes, explaining the science behind the view that they'll have from space. In 2022, he started his company, Planetary Experience Consulting. So please help us welcome Kirby Runyon.
Thank you so much, Izzy. It's an honor to be here with you today. And that was I remember with fondness when we were at the Space Tourism Conference, helping John Spencer here in the audience stuff name tags. And we were looking at the moon. I was doing a little bit of my NASA-funded day job. And if I can go ahead and share screen, I want to take people on a visual tour of the moon here. It says host has disabled participant screen sharing, if you know how to fix that. If not, one of the things I really want to show people with the moon is a way that you can explore the moon visually yourself. And I'm just going to drop something in the chat right here. It's called Quick Map, and it's put out by Arizona State University. There we go. Okay, so let me know. Hopefully everyone should see my screen.
We got it.
Great. Okay, so with the link that I just put in the chat, anyone can go to this. And this is a tool that we planetary geologists use all the time to help us in our research. And so anyone can go here, quickmap.lroc.asu.edu. And when it first comes up, you see the moon as you would see it in the night sky. and there's all kinds of things that you can turn on. I like to go into what's called the equidistant cylindrical projection, and that's the moon just flattened out as a nice flat map that you can look at. And this shows you on the far left and the far right, the far side of the moon that never faces Earth. Sometimes people call it the dark side of the moon. It gets just as much sunlight as the near side, but it always faces away from Earth. So it's not really the dark side, but it is the far side. One of the areas where I'm doing high resolution geologic mapping is right here. And I'll go back to how the moon looks to you in the nighttime sky. And it's this little black spot over here on the far left side, the western edge of the moon. This is part of all the dark stuff you're seeing is actually cooled lava. In fact, everywhere you see darkness on the moon like this, it's because you're looking at cooled lava, the same type of lava basically that erupts in Hawaii or Iceland. And you can zoom in on here almost endlessly. It's really easy to zoom. It's sort of like Google Earth for the moon. And what I love to do is to zoom way down inside craters. In fact, the younger the craters, the better. In fact, I'm going to go to one of my favorite craters to the west of here. This is on a part of the moon that you can't see from Earth. And it's one of my favorite basins. It's called Oriental Basin. And it's the series of concentric mountain ranges. It looks like a bullseye. And this is the most recent large impact basin to form. When a huge asteroid hit the moon about 3.8 billion years ago, it blasted this huge hole in the ground. And when meteoroids and asteroids collide in space, there's all that energy. And that energy can go really into two different things. One of those deposits of energy is just digging that big hole in the ground and making a crater. The second way that energy gets put into the target is in the form of heat. When you release all the energy so fast, it's so hot. How hot is it? It's so hot that it not only melts some of the rock, it actually vaporizes some of the rock as well, rock gas. In fact, it's almost like red hot lava, except it's so hot, it's not red hot, it would be glowing white hot. It's basically the same thing as lava, except that it never came up out of a volcano. It just got melted in place. And as you zoom in on these younger craters, you can actually see where the floors were molten. And what's great about QuickMap is the further you zoom in, the more detail you get, and it loads data from a spacecraft that's been orbiting the moon since 2009 called the Lunar Reconnaissance Orbiter. And it's basically a spy satellite around the moon. And it has been taking very high resolution pictures of the moon. You might think, well, we've been to the moon. Yeah, we've been to the moon a lot of times with both robots and humans, but believe it or not, it took us until the last roughly 13 years before we could get the best images ever of the entire part of the moon. And as you zoom in here, it just keeps loading higher and higher resolution data, and you can just drill down endlessly. One of my favorite features on the moon is actually over here in Lowell Crater. This is what's crazy about Lowell Crater is it's 50 miles across. So imagine your city with, you maybe have like a beltway around the city. This is basically the size of a city's beltway around it. So it's a big old hole in the ground. There's a Rocky Mountain size 10,000 foot class mountain right here in the middle. In fact, every large crater on the moon or any planetary body gets a mountain that grows right out of the middle, just from the force of the impact. And there's this little crater right here. And by little, I mean, it's only like, 3 to 5 miles across. But if we zoom in here, you can see where the bottom puddle of this, see how it's all gnarly and kind of lumpy and everything? This is where rock got melted from the heat of that impact. It flowed. You can see these like lobe feature things here. It looks like mud flowing downhill. This was basically lava flowing down the moon. You can even see where it's cracked. And if you've ever been to Hawaii or Iceland, and actually there's a lot of places in New Mexico and Arizona where I take sometimes future astronauts on geology hikes of Earth's geology. It's very similar to those features that you see in Arizona, Hawaii, New Mexico, Iceland, where there either are or have been volcanoes. So sometimes when people make fun of the moon and call it an old dead rock, no. The moon is this gorgeous black and white Ansel Adams photographic wonderland. And the geology is one of the ways that I love to dive inside of it, get to know the moon's secrets better. The mapping that I'm doing with NASA funding is, we've mapped the moon before, but not at this level of detail in the exact locations that I'm doing it. And one of the reasons I'm doing it is for the long-term picture of finding potential exploration zones where people could go or where robots could go to figure out how old very specific types of rocks are. And those specific types of rocks that I want to find out the ages to are impact melt deposits, like exactly what you're seeing on the screen right here. Whenever a rock melts and then cools, it locks in its age. You can go look at the trace radioactive elements in there, which act as a sort of natural clock. And when a rock cools from a molten state, it locks in that time of formation. And whatever date you get when you age date it, using some like uranium, lead, potassium, thorium, is when that rock cooled. And so we can figure out the moon's history of getting the tar beaten out of it. And by extension, we can infer that same geologic history for Earth, because Earth doesn't have that geologic record, because we have this pesky stuff called water, this other pesky stuff called life, we've got plate tectonics, and it just ruins our cratering geologic record. So I like to think of the moon as Earth's attic. You've got to go upstairs to find the really old relics of when the Earth-Moon system formed. If you take a pair of binoculars out, I've got a pair of binoculars right over here. That's all you need to explore the moon out in the sky, in addition to, I would argue, this website. And one of the famous craters, Izzy, I don't know how much time we have, so I'll just touch on one more crater. And then, actually, let's do something more fun than that. Let's zoom in on one of the Apollo landing sites. This is the most recent place that astronauts visited. It's over here at the boundary between what's called Mare Serenitatis and Mare Tranquillitatis. This is where the Apollo 11 astronauts, Neil and Buzz, landed in 1969, down in here on this big flat lava plain. But Apollo 17, if you know exactly where to zoom in, and I do, you can zoom in right exactly into what's called the Valley of Taurus Littrow. And it's this valley in the mountains. These mountains were formed in a matter of minutes after an asteroid formed a multi-hundred-mile wide impact basin, Mare Serenitatis, in the moon's crust. And as we zoom in here, we get finer and finer detail. We have a place where there's a moonquake that formed this thrust fault called a wrinkle ridge. There was an avalanche of white rocky materials avalanching off this mountain right here. And if you humor me for 1 second, I might even be able to zoom in on the Apollo 17 lunar module, the Challenger, not the space shuttle, the lunar module. There it is. In all its pixelated glory, taken by the Lunar Reconnaissance Orbiter camera. And in fact, if we change some of the mapping features here, we can even get its shadows to show up. So one trick that we geologists use to see things on the surface that are too small is to use the shadows of the things that would normally be too small. And hopefully we'll get a really nice dramatic shadow here as we load in different images. What's great, there we go, that's a nice one. So there's the lunar module Challenger, and there's its shadow going off to the west as the morning sun was shining in the east. The sun rises in the east and sets on the west on the moon, just like it does on Earth. So so this is a way to explore the moon. I think some of the things you see here, well, these are some of the boulders that the astronauts visited. As a planetary geologist, Apollo 17 is one of my favorite missions because one of the astronauts, Dr. Jack Schmidt, was also a geologist. He still is a geologist. He's still alive, and he's still active in the field, and I see him at conferences. So he's a fun guy to talk to because he's actually walked here on the moon. So between this website, Quick Map, and a pair of binoculars, I hope you have a lot of fun exploring the moon.
Awesome, awesome. And do we have 1 or 2 questions before we move on? Let's see. Liam says amazing, and I agree. All right, we are going to go into the next phase.
There's one question.
Yes, okay.
Yes, Donnie?
Yes. Hi, can you hear me?
Yes.
Yes, we can.
Yeah, sorry. I missed the last part where Dr. Kirby just mentioned that there's some name of an astronaut who actually walked on the moon, and while he was zooming out. So this was like just like a few minutes, like a minute ago or something. So if you could just say that again. So I'm like kind of taking notes. Of course, it's so that I could obviously just do my own research work as well to fill myself up with all this amazing information. And
Yep.
when you said he's alive, that would be like just crazy to talk to him. I mean, wow.
Yep. I put it in the chat. His name is Dr. Jack Schmidt, Harrison Schmidt. He goes by Jack, and he's the only PhD geologist to have walked on the moon.
Thank you.
Awesome. All right. So we've looked at the moon. So now we're going to research the moon. It's a vital step in the lunar process. Our next guest was also a speaker at the Space Tourism Conference. Melissa Roth and Kirby were both on the space mining panel. And she was also a guest on my podcast as we started the journey into the space industry series. Melissa Roth, co-owner and lead researcher at Off Planet Research. She provides mission assurance in space-based technology through the use of simulants like Regolith, hardware development and testing and consulting. They have received several NASA SBIR grants to develop dust-tolerant technologies. With her background in mechanical engineering, Melissa works with clients to ensure that they get the best simulant for their testing to help them learn to survive and thrive in some of the harshest environments in our solar system. Please help me welcome Melissa Roth with Off Planet Research.
Hello, and so as Izzy said, Washington State, and I want to thank Space for Kentucky for having me today. I will be speaking about lunar regolith, the challenges and the resources within it and in deeper space. So off-planet research simulates or recreates extraterrestrial environments for testing spacecraft and landed technology with a current focus on the lunar environment. As engineers, we know testing and good testing materials are important for increasing mission assurance, cost effectiveness, and to speed the development of space-based technologies. OPR was founded in 2015, and we spent several years developing our lunar regolith simulant production methods to mimic those natural formation processes on the moon to avoid smoothing the particles or contributing high levels of contamination. And we have also developed lunar regolith icy simulants, provide consulting expertise on working with lunar regolith, and conduct component testing. We have also been developing our own technologies such as seals, attachment methods, and dust covers. And now to harken back a little bit to what Kirby was saying, he gave a great preamble, and so I'll just kind of do a little bit of an overview. Lunar regolith is very challenging. In fact, the environment on the moon is one of the most challenging that humanity has ever encountered. In addition to the extreme temperatures of plus or minus 260 degrees Fahrenheit, one of the most difficult parts of this environment is the nature of the regolith. Earth's soil contains organic material, and the particles are formed by wind-blown and water processes, which makes them relatively round and smooth. The regolith or soil on airless bodies, such as the moon, have no organics, are not altered by moisture, and are entirely formed by impact and explosive processes. This means that these particles are very hard and covered in broken surfaces with sharp edges, as in that image in the middle.
I think we lost you, Melissa. Uh-oh.
All
There
these
you are.
factors, regolith
There you are.
particles easily out regolith, but Kirby filled us in.
Yeah, we lost you for a minute, so.
Okay. Option
So
number 2 is that I try and get audio through my cell phone.
Okay.
Do you think that it would be worth pausing for a minute?
Go ahead and call in and
Perfect. Kirby, would you like to talk about craters and micrometeorites on Earth for a minute?
Sure, no problem. I'll pinch it for you. Okay, what you see on the top part of the screen there is Earth's best preserved impact crater called Meteor Barringer Crater, just about 45 minutes east of Flagstaff, Arizona. So when you're going to see the Grand Canyon, drive a few hours to your east and go see Meteor Crater. It is awe-inspiring to think that that thing formed in seconds, and you could fit 3 downtown Philadelphias on its floor. An iron meteoroid dug out that hole in the ground 55,000 years ago. And impact craters range from hundreds to thousands of miles in diameter on the large scale. In other words, just barely not big enough to have destroyed the planet or moon in question. In fact, most planets or moons have a crater on it where if the crater had been any bigger, the planet or moon would not be there because it would have gotten broken apart. And so that happened a lot in the early solar system, we believe. And so craters can happen all the way on the planetary scale, right on down on a continuous spectrum down to microscopic craters, almost microscopic, sometimes called the zap pits. And if you pick up a moon rock, like you can just go do, you can often see little pinprick holes on the outside of the rock. And then you can see these little dark splotches around there. And the little dark splotches around there are where literally pieces of dust impacting that rock at many miles or kilometers per second vaporized and melted a little bit of rock. That little bit of rock that melted got kind of squirted out of the little pinprick hole, and then it formed like a little, and then it cooled very quickly. And when you cool a rock very quickly, it forms a glass. In fact, obsidian is a volcanic rock that cools so quickly that it's a glass. And so that's what you see here on the bottom here is where you get micrometeoroids made out of dust hitting the surface of a rock, creating that dark area called a patina. That's sort of a 10-cent geology word, right around those little zap pits. And one thing that happens, I've been talking about impact melt, the heat from an impact, and it creates little blebs of lava, and those little blebs of lava can glue together adjacent chunks of rock and dust and soil, and the gluing of it together forms what we call agglutinates, shown on the left there in an electron microscope image. Like these things are like a few millimeters, like they're like a grain of sand, but they are like lunar razor blades of death that you don't want to breathe in, that have a tendency of destroying. Oh, Melissa, anyone know how to unmute on phone? Is it *6? That's just a guess.
Can you hear me now, Kirby?
Yes, we can hear you now.
Perfect. Kirby, you are wonderful. You are amazing. You deserve all the gold stars.
Glad to help out. Thank you.
Okay. So sorry about that, guys. That was very chaotic. Always fun. Okay. I'll just skip this because from what I could hear as I was frantically typing buttons, I think Kirby covered it. So we are going to go down to the next slide. And again, Kirby kind of already covered this.
If you wanted to cover more.
Oh, no, you covered more than I was going to, so you're perfect.
Okay.
Let's try to keep this to 10 minutes. We'll see how I can do. So as Kirby said, there are two kind of primary types of regions on the moon. You have the Mare and the Highland, and then you also have two sides of the moon, the side we see, the near side, and the far side that we don't get to see, but is ironically not very dark, despite what it's often called. And so in the upper left, you see some basalt, which is very a common component of those Mare regions. And on the right, you see some anorthosite, which is a common component of the Highland region. Okay, now back on track. In this iconic photo of Buzz Aldrin on the left, you're going to note how white his suit is, with the exception of a couple of dark spots on his knees from a fall. On the right, James Irwin's bottom half is absolutely coated in dark gray regolith. Not only is the regolith abrasive and destructive to the fabrics and joints, but the astronauts were susceptible to overheating as the pristine white design was meant to help reflect heat. A new dust-generating system arrived on the moon, starting with Apollo 15 in the form of the Lunar Roving Vehicle. While these LRVs dramatically increased the distance traveled and mission capabilities, they also stirred up even more dust to coat the LRV, the astronauts, and their instruments. In regards to cleaning the suits after each EVA, Gene Cernan said, probably the most difficult job of all the closeouts was trying to dust the suits. In the photo on the right, a very dirty Gene Cernan can be seen in the lunar module after taking off his suit. What I find fascinating about this photo is that theoretically, Gene was protected from the regolith in his EVA suit. His skin was never exposed to regolith that was outside the lunar module. And despite all that time spent cleaning, the regolith that did enter the lunar module very quickly spread around the capsule. Astronauts developed lunar hay fever as a result of breathing in these fine abrasive particles. In fact, researchers are now studying how long-term exposure to lunar dust might affect the lungs of future astronauts. This table shows some of the statistics of the Apollo EVAs. The 6 missions over 3.5 years show a rapid advancement in the amount of time spent outside the lunar module, the total distance traveled, and the quantity of samples brought back. Hopefully, now that you see the table, you can see that LRV dramatically increased the distance covered by the Apollo astronauts and really the variety of samples they were able to bring back. That said, the longest astronauts have spent on the lunar surface is still less than 24 hours. If the dust was so abrasive that it wore through 3 layers of the Kevlar-like material on Jack Schmidt's boots, how will our technology survive weeks to months on the lunar surface? Should I continue with the slides, or would it be better to just have a phone conversation, guys?
Well, unless there's something in particular you wanted to show, because it just bumped your slides off.
Oh no, I'm so sorry. Okay, well, I have this lovely presentation that doesn't see like you can see, so perfect. We'll just continue on the phone. So what many national space agencies and private organizations are doing is creating visions for a long-term sustainable presence on the moon and in deeper space. With 50 years since the last human mission to the moon, how can we make these visions a reality? NASA's solution is the Artemis program, which is going to be a series of missions with the goal of landing humans on the moon in the next few years. So normally what happens is the industry struggles with bridging the gap between technology and business. While still applicable for the space industry, the bigger struggle is really going to be bridging the gap between technology designed for environments on Earth and technology designed for the moon and other worlds, of which we often have incomplete or little knowledge. These unknowns are called strategic knowledge gaps, or SKGs, and these are questions that researchers and industry experts try to answer or plan to answer through a mission. So in order for Artemis to be successful, we really need to understand dust mitigation better, and that's going to include being able to reduce, remove, or eliminate dust. And as I mentioned earlier, Apollo Air technology had some issues operating in the dusty environments, and they just kind of had to live with it. Well, for a vision of humans inhabiting the moon, you can't just live with the dust. We need to either prevent dust from collecting on surfaces in the first place, or we need to create new technology that is more durable for this harsh environment. Likely it's going to be a combination of both. In addition to procedural techniques, cleaning processes, and strict planning to avoid hazards, astronauts use dust brushes, dust covers, and rover fenders to reduce or remove dust. With particles that are very fine and receptive to static charge, these brushes were really only partially effective. And repairs will be challenging as well when that vital component breaks on the moon and the closest hardware store is 239,000 miles away. There were several instances where we saw this happen during the Apollo missions, but the final one almost prevented the final lunar roving EVA of the Apollo era. At the end of the first Apollo 17 EVA, Gene Cernan's hammer popped off a fender. And without that fender extension protecting them from the dust, the LRV was a serious hazard. Due to reduced gravity, any dust that's kicked up in the air is going to go a lot further than it would on Earth. So the astronauts described riding without the fender to cause massive rooster tails behind them. This airborne dust was spreading all over their instruments and the bright white suits, and it was going to absorb heat from the sun and could overheat the instruments if they weren't able to shed enough. While the astronauts slept, the team in Houston had to create a replacement fender with only the materials that the astronauts had on the moon. Their solution was to attach 4 of the 28 lunar mats with duct tape and 2 telescope alignment clamps. And I feel like this is a really interesting story because it illustrates the importance of being able to think on your feet, adapt technology using very limited resources, and learn from experience how to mitigate dust. Because without this fix, the only geologist to set foot on the moon might not have had the opportunity to discover a new orange glassy regolith on the edge of a crater. Now, I had to set aside the business case for a minute, but that's going to be how we can afford a sustained human presence, because science and research goals can only fund so many missions. Governments can only fund so many missions. It'd be hard to make the case for a long-term presence without being able to show the financials of why we need to go, and not just why we want to go. And so this is where lunar resources really come into play. We need to be able to utilize the resources of the moon, Mars, and asteroids to literally propel ourselves into deeper space. And so this is where that term ISRU, or in situ resource utilization, comes in, where you live off the land and use the resources around you. Luckily, there are a lot of resources that can be extracted from regolith, including about 40% oxygen by mass of the regolith, and then a lot of glassy minerals as well. There are also a variety of metals in the regolith, as well as volatiles are expected in the polar regions. The 2009 L-Cross mission discovered water, carbon dioxide, ammonia, and methane, to name a few, in the ejecta plume. And even though that's one point of ground truth, there are many unknowns for volatiles. However, they really have revolutionized how lunar resources can be used. It can be used for rocket fuel, breathable air, drinking water, and in agriculture. The rare earth elements in their unrefined state can be exported back to Earth for many applications like electronics. Or it can also be used in sintering and 3D printing applications to make tools or construct buildings, protective thermal and impact shields, and roads. And so I had some information about the kind of value of the space industry. So hopefully someone else can cover that, since it was on my slides. And with that, I really just want to end on this, and that is that ultimately the reason for becoming a multi-planet civilization is to better the lives of everyone and ensure the survival of humanity. As we begin the next stage of space development, we need to ensure that we work to make this vision a reality while not repeating the errors of our past. And learning to survive and thrive on the moon is our first step towards this new existence. In the future, there will hopefully be thousands of people working and living in space. So thank you for your time, and I welcome any questions if there are any after all of that.
Well, we do have one in the chat, and it is: Are you working on new spacesuit? Are you working on new spacesuit companies, and what are the challenges of that?
Yeah, so I know that there are some spacesuit companies out there, two of whom have received grants from NASA. And so I don't know if our NASA speaker can speak more to that. But one of them is, I think, for space, and the other is actually designed for the landed missions. And we ourselves have had some grants focused on elements of the NASA spacesuits. And so there's a lot of work that's really being done in this area to make them more mobile, more streamlined, and really help set the astronauts up for successful EVAs.
Awesome. Are there any other questions? Go ahead.
Oh, I was going to say, has the regolith been found in the respiratory systems? That's a great question, and I'm sure there is plenty of data out there. I can't imagine they did not find some if they thought to look. In fact, I do think I remember reading something about that. That said, there is great concern about regolith in the respiratory system, and so I know there's a lot of research being done, and some of it is using our simulants on the effect on cells, on the effect on how this is going to affect humans short term, whether it's through that lunar hay fever, or if it's going to have long-term ramifications due to not only some of the components, but how abrasive and how fine this material is.
All right. So we've looked at the moon and dreamed about the moon. We've practiced on Earth for the moon. Now it's time to land on the moon. Chris Colbert is a project officer of NASA's Commercial Payload Services, or the CLPS program. And here's a clip for what that is. NASA's Commercial Lunar Payload Services, or CLPS, is an initiative that allows rapid acquisition of lunar delivery services from American companies for payloads that advance capabilities for science, exploration, or commercial development of the moon. Investigations and demonstrations launched on the commercial moon flights will help the agency study Earth's nearest neighbor under the Artemis approach. So please welcome Chris Colbert.
Thank you very
much. Are you there,
much.
Chris? There we are.
Yeah, can you hear me? Yeah, can you all hear me?
We can. Yes, we can.
Great. So let me try sharing my screen and see how that goes. All right, let's see. It looks like that's working. All right, so let's switch gears a little bit. You just heard a lot about what happened in Apollo. NASA is very interested in going back to the moon and establishing, consistent with today's theme, an economy at the moon. But we need to do it a different way. We want it to be sustainable. We want it to last a long time. So there's a lot of different efforts going on inside NASA today to look at utilizing commercial industry more effectively and more consistently. We're one of many efforts. Ours is the one focused on going to the moon, and because of who we are, we'll be the first ones to go to the moon. But I will tell you the limitations. We do not do people. What I'm working on takes payloads to the moon, so they're smaller landers. And in some interesting ways, we're trying to go farther than almost anything else the agency's done towards relying upon commercial endeavors and commercial capability. So let me see. Yeah, there we go. So in many ways, what CLIPS is about more than anything else is an innovative approach towards looking at how NASA procures services to deliver payloads to the moon. We aren't designing the landers. We're not responsible for the mission. We actually tell people these are not NASA missions. These are NASA payloads on a commercial mission. For a real simple thumbnail, think FedEx to the moon. We will hand our package to a commercial provider. That's up to the commercial provider to decide how to get it to the moon. And then once it's on the moon, they help us operate it and gather data for us. This is very different than the way we've done previous space missions, not just to the moon, but everywhere. In this model, NASA is not telling the vendors how to build a lander. We actually don't even, require them to explain that to us. It's their job to build a lander. It's their job to provide a launch provider. We ask them, we give them a set of requirements to say, here's our payload. This is the science we want to perform or the demonstration we need to see. You figure out how to get it to the moon and perform those activities for us. So first and foremost, CLIPS is a process to allow NASA to get payloads to the moon in a very different way. We're hoping by allowing much more control and authority in the commercial side of the fence that we get lower costs and faster pace. And while we haven't landed on the moon yet, we have a chance to have as many as 3 landings by the end of this year, though it's already June, so we'll see if we get there. We're utilizing firm fixed price contracts that go to as many as 14 companies. They have to compete for each one of those contracts. We've awarded 8 of them so far. Actually, we've awarded 9, but 1 company went bankrupt, so they don't count anymore. We have 8 missions to the moon planned over the next few years. In the long run, we hope to be just one of many customers. We don't want to be the only customer or even the primary customer. And in fact, on every one of the missions we've awarded so far, the companies are not only carrying NASA payloads, they are flying commercial payloads paid for by other entities, either other countries, other companies, or even artists have sponsored activities at the moon. All right, let me go to the next chart. Here are the companies that are in our, what we call a vendor pool, the companies that are eligible to send payloads to the moon. As I mentioned, there's 14 of them. This represents the ones that were originally awarded. This is the aerospace industry, so some changes are occurring. Maston went bankrupt and they're no longer in business. They got bought out by Astrobotic. Deep Space Systems got bought out by Redwire. Tyvek was absorbed by Terra Nova. There's a number of companies here. Only 5 of them have won task orders. The others are still competing, but have not yet been awarded an opportunity to fly NASA payloads to the moon. There's a number of names you'll recognize here. Some of the big names in the industry, like SpaceX or Blue Origin or Lockheed, now Sierra Space. There's also some small companies you may not have heard of before. So we're trying to engage with a much broader community than the traditional aerospace companies. And in fact, most of the awards to date have gone to small companies who are doing this for their very first time. This is a nice chart that kind of lays out the big picture of how our missions fit into the broader Artemis strategy. This kind of lays out everything that's happening over the next 4 to 5 years. You can see it on the outer spiral. You can see all of the CLIPS activities that will land on the moon. We have three payloads, or three groups of payloads awarded to 2 different companies that are at least currently scheduled to land on the moon this calendar year. 2 of them from a company called Intuitive Machines, which is based here in Houston, and the third from a company called Astrobotic that's based in Pittsburgh. Astrobotic's lander is finished. The payloads are already integrated. We're just waiting for their ride to the moon. They're scheduled to fly on the first flight of the ULA Vulcan. And as I suspect many of you know, the ULA Vulcan had some testing issues earlier this year, and they're still working through that. So we're not actually sure when that one will fly. Intuitive Machines has 2 missions scheduled this year. The first lander is almost done. Should be ready within a month or 2 for a ride to the moon, but they're still negotiating with SpaceX for when they'll get their opportunity. You probably know SpaceX is flying more missions than have ever been flown before in 1 year. And they got huge demand, and Intuitive Machines is fighting for their spot in line. So we're hopeful they get at least 1 of those shots this year, and maybe 2 before the end of the year. After that, next year we have 3 more opportunities to land on the moon. 1 from a company called Firefly, based in Austin, Texas area. A 3rd mission from Intuitive Machines next year, and then Astrobotic's 2nd mission. That one's notable because it's a much larger mission. That will be carrying the Viper rover that NASA's building that will be exploring regions of the South Pole for volatiles, the kinds of materials that are left on the moon that might be able to be turned into water or oxygen resources for future human habitation. And Viper is our first attempt to do some ground truthing of the kind of data that LCROSS suggested might be available, particularly in the permanently shadowed regions on the moon. The rest of our missions are in the 100-kilogram class range, which is not nothing. That's actually a fair amount of capability. The Viper mission is closer to 500 kilograms, so it's a larger lander and more capability required. To help calibrate that for you, human missions on the moon need closer to 10 to 15 metric tons to be taken to the surface of the moon, a much, much larger lander. The Apollo missions were in the range of 4 to 5 metric tons to the surface of the moon. So the landers that we're sponsoring right now are much smaller, but landing on the moon is still pretty hard to do. There have been 3 attempts in the last 3 years, 1 by a private company out of Israel, 1 by the India Space Agency, and then a 3rd one just a couple months ago from a Japanese private company. All 3 of them failed. Only the Chinese government missions have successfully landed the moon in the last decade. So we're hoping these small companies that NASA is sponsoring will be the next ones to do so. And we got a lot of chances over the next few years. The inner circle here kind of shows how what we're doing on CLIPS starts laying groundwork for the future human exploration under the larger Artemis program. We've already had Artemis 1 fly to the moon as an uncrewed mission that happened last year. We're hoping that Artemis 2, the first crewed demo, will happen next year in 2024. And then the first lunar landing with humans again, right now, 2025, 2026 timeframe, though that's probably a little shaky still in terms of pinning that down. The kind of work we're doing under CLIPS is meant to provide scientific data that helps better understand the moon, particularly helping us understand things like the location and the ability to utilize resources that might be available, particularly in the polar regions on the moon. Give us better information about the environment of the moon, both thermal, radiation environments, understanding some of the basics of how humans might be able to live and operate in the moon longer term. And we're also doing just basic science. One of the missions that the 2nd Firefly mission will be to the first US mission to the far side of the moon, where we'll be doing some really, really groundbreaking deep space radio astronomy in an environment that you really can't replicate anywhere else, anywhere on Earth. Radio quiet that you can't get without being, far side of the moon where you can't see Earth at all. And in fact, they'll actually be waiting till Saturn and Jupiter, Uranus, some of the bigger planets are out of the sky, so they can't provide background radio noise. So there's some really fascinating deep space science that we'll be doing from the moon. We're doing testing of landing systems, particularly hazard avoidance and terrain navigation that will be needed for human exploration down the road. We'll be testing out some power infrastructure that will be scaled up for human activities further down the road. CLIPS is really all about, doing that preparatory work that allows the future human exploration to to be more successful, to be safer, and to establish long-term capabilities. And we're doing it utilizing commercial missions. And we've chartered, like I said, 9 of them now. One that didn't make it, but we're redistributing those payloads to the other missions. And just waiting for the chance to demonstrate that this works using a very different style. So that's all my charts. That's kind of a quick summary, but I thought I'd leave room for some questions.
Awesome. Awesome. Do we have some questions? Let's see.
Yeah, we got a note from Jack noting that the Vulcan had a very successful hot fire last night. We watched that. Went well. So that's actually, we hope, a very good sign. We're hoping that they could fly by the end of the summer, although ULA is not telling us. I'm not sure they're telling anybody. But yeah, Astrobotic's ready to go. As soon as ULA is ready to fly that mission, Astrobotic's buttoned up, ready to be shipped to the Cape and integrated onto the Vulcan. So yeah, we're hopeful that we can get that maybe as soon as this summer.
Awesome. Awesome. Well, we are approaching some very exciting times, you know, with Artemis 1 kicking us off. So are there any other questions before we move on? This is the meat and bones of the actual industry on the moon. This is where people start to really bring products, and this is our first step, and not literally the first step. This is where we get there. And yeah, so
we are hopeful that, you know, in essence, NASA as the anchor tenant is important to help the industry get started, to kind of grease the skids of the economy. But we're optimistic that over time, NASA doesn't have to be paying most of the bills, that we're just one of many customers. But somebody has to, you know, help take those early steps and help absorb some of the cost risk. So that's what we're doing right now.
Well, no, a lot of what you do, the technology comes back down to Earth, and NASA spin-off technology and technology transfer. So it benefits us here on planet. So let's see. In your opinion, autonomous missions instead of sending humans, which one would you vouch for? I think due to the safety of humans, going to the moon has delayed what could have been done much earlier.
Yeah, you know, that's actually, I think the answer is yes to both. If you take a look at terrestrial activities, we utilize automation in a wide variety of areas, but we also have humans. They bring different capabilities to the table. The technology is maturing rapidly, but I think it is a true statement that landing on the moon is a relatively risky endeavor. The Apollo crews were very fortunate. We had one significant accident. We thankfully brought all that crew home safely. But it is not easy. Like I said, even 60 years later, when we know a lot more about technology, three different entities have failed to land on the moon in the last 3 years. So landing on the moon is hard. I think you're going to see a mix of autonomous, smaller scale missions along with human habitation. It's really hard to put in situ the expertise that just one human brings to the table. I've actually talked to Jack Schmidt about this. Jack will talk at length about the importance of having a trained geologist and what he understood in situ, able to look at the rocks, able to look at the surface and make decisions about what would be important to bring back that we still can't have AI systems do effectively. It's really important to be able to get that expertise in the location, and humans right now are still the best way to do that. But it's expensive. It takes a very large lander to take humans to the surface. I think the smaller lander is going to bring a lot of autonomous capability and allow us to do an awful lot of exploration before we get the humans there.
Yes, and I would like to point out that also it's physically it's hard to get to the moon, but it's also politically hard to get to the moon. So part of the challenge has been getting funding through Congress and making it important. But with the commercial coming on board and the commercial players flipping the bill a little bit on this, it has opened the door to it not being as politically fragile of a process. So I think that for once we're going to see a lot of amazing things happen just because of the commercial aspect of this industry.
All right, we've got one more question online, then we'll move on to the next speaker. So Jack asked, what is your recommendation on lunar zoning or protected areas, including areas around spacecraft or a company or government lander? So this is a really complicated discussion. Space law is still in many ways a nascent industry. There are this isn't the Wild West, or discovering the Western Hemisphere back 1500 years ago type thing. There is both outer space treaty and signatories across the world. There are international agreements already that help create a framework for how we might cooperate. But there's relatively little testing of that law. And it's because it's so hard to get to and so few entities get there, it's going to be hard to demonstrate exactly how you can secure your part of the moon, if you will. There are US laws that require US commercial entities to respect the Apollo landing sites and not land too close to them and blast them with their ejecta or their plumes from landing. But there's relatively little way to enforce those laws today. This is an area that will have to grow along with human activities on the moon. I think there's a lot of work that will have to occur there. But this isn't brand new. We've gone through a lot of this on Earth before, and there is already some frameworks, the Artemis Accord being another example, for reaching international agreement about how we all work together to take advantage of space utilization and space resources.
All right. Well, thank you, Chris, for that. And so we've made it to the moon. Now we need to get to the planning to stay part of the evening. And for this, we have Britt Duffy Adkins. She was a speaker at the Space Tourism Conference and the Human to Mars Conference that I attended a few weeks ago. And her talk was amazing. She is the CEO of Celestial Citizen, a space urban planning company focused on building sustainable space communities by bringing together people, systems, and technology. She hosts the Celestial Citizen podcast and built a space media platform with over 100,000 followers. She holds degrees from USC, Colorado School of Mines, MIT, and Wellesley College. And I probably mangled that name. I apologize. After her talk at the Humans to Mars, the agenda for this evening began to take form. And so if you would give a warm welcome to Britt Duffy Adkins with Planning the Moon.
Thank you so much, Izzy. And it's great to be here. I'm really excited. I think that the flow of the topics and themes is totally spot on. I love it. So let me pull up my presentation here and we can get started. Oh, Izzy, I think you might be muted.
We're all good.
Okay, great. I'm going to go ahead and hide this so that you all, let's see, hide. Do that, and we'll also hide this. There we go. Okay, great. So as Izzy mentioned, I'm Britt Duffy Adkins. I'm the CEO and founder of Celestial Citizen. And not to sort of repeat what was just said, but we are a space urban planning company. We are seeking to help consult on mission planning and things like that, but also finding unique opportunities here, even terrestrially, to help build out space ecosystems and communities that are driven by the growth of the space industry to support all of the progress that we're making here on this planet as we look to build towards that future in space. And then, of course, also helping to cultivate conversation around what that future might look like from the very early days of planning out infrastructure and early base design and things like that. In the meantime, to do that, as Izzy mentioned, we offer a media platform and have built out a pretty robust community there. So I will share more about that as we go through this. Hopefully let's get to the next slide here. There we go. Okay. This was already mentioned, but I will just kind of start off by saying that, my background is in urban planning, architecture, and space resources. I think one of the most important things that we can do for the future of space exploration is to really find ways to bring together all these different parts of the industry and also industries that are tangential to it, and really find ways to better understand how interconnected all of those different disciplines are and all of those different sectors might be. I'm a big believer in outsider perspective. And so I think any opportunity that we have to bring in people that have a unique perspective on how the space industry might look is a very valuable point of feedback. So definitely trying to look for opportunities for that. And the other thing that's really critical is that the better job we do at planning here on this planet for what that future of space looks like, will really be able to enable a greater set of options tomorrow. So we should really be thinking about space exploration, space infrastructure, and the future of humans actually living and working in space as a generational endeavor. So we don't want to be too nearsighted in the way that we are looking at these things. And we want to make sure that we're leaving open a lot of opportunities, knowing that we can't predict the future. So what exactly is space urban planning? And I like when I'm in a group and I can actually see hands more easily to ask people if they're already familiar with urban planning. But for those that aren't, I'll just kind of give a brief context here. So urban planning for cities and towns here terrestrially is really focused on not only the architecture and the urban design, but also looking at the political, the social, the economic factors that go into building out communities and cities and places that thrive, right? So it's really looking at it from a very holistic approach. Therefore, usually within urban planning, you might have people specializing in different aspects of that. I myself have always been really interested in not only sort of the broad vision and design of planning out from a macro level, how things might look, almost sort of similar to systems engineering, but I really like the public outreach and the community engagement side of that. So really getting people excited about what we're building and also trying to integrate that feedback in a way that is helpful for design and for also allowing people to really feel heard in the process as well. So for space, the interesting thing is that I actually think that this can be applied quite usefully to what we're doing in space, and it's not without precedent. So actually, there's a really interesting book that I wrote about on our website where, they had talked about this history that existed after the Apollo missions, where you had a lot of people, because of budget cuts and things like that, coming out of NASA and actually taking jobs as urban planners. And so that was always kind of interesting to me that people seem to naturally understand how engineers could be helpful on the urban planning side. And perhaps I'll also just caveat that with there were some drawbacks as well in terms of taking a purely engineering approach to the way that we think about cities and planning them. But on the flip side, it's curious to me that we haven't really thought about how much urban planners can bring to the space community. So that's kind of what I'd like to highlight here today. Space urban planning, it can help us maintain continued channels of democratic participation, can help us integrate those ideas, as I mentioned before, and really turn that into actionable urban and institutional design. Also, urban planners do a lot of stakeholder analysis to try to understand what the landscape is in terms of interests, what people are passionate about, what is really going to move the needle in terms of actually bringing people to the table and finding a cooperative solution that is workable for all, and also encouraging all of the discourse and dialogue with that. I'd also mention the cross-industry collaboration already. But another key feature is establishing a participatory framework for doing this as well. So really, empowering all humans everywhere to see themselves as celestial citizens, or if not a celestial citizen, then whatever they prefer, but they should really start to see themselves as being a part of this process. We want everybody to see themselves as potentially being a part of this wonderful future we're planning in space. And of course, another key aspect of that is information. So we need to make sure that the information that we're providing people is accessible and digestible. You shouldn't have to need a PhD or a master's degree or what have you to understand what's going on in space, at least at a conceptual level. And so a big part of what we do through our podcasts, through our social media platform, and also through our newsletters and even video content is we really try to communicate the latest of what's going on in the space industry. And we try to sort of distill that down for folks so that somebody who maybe just has a passing curiosity in space can suddenly be brought into this community, start to learn more, and maybe find that they actually are really passionate or very interested in it. We're trying to broaden the reach of space exploration to, beyond the people that are already in the industry. And we really try to reach, especially those younger generations that will very quickly be needed to support these space futures that we're talking about. So some of the knowledge gaps that I believe exist out there today in terms of when we think about lunar infrastructure and eventually lunar settlement is really balancing all the different objectives that are there. So thinking about, space resources, science objectives, commercial objectives, cultural objectives, all of these things need to be thought about and considered so that we can really make sure that we're not alienating any one group in the process. We also need, greater comprehensive surface studies and land surveys. As somebody kind of coming at it from the architecture and planning side of things, it's very hard to see a future in which we can really achieve structures on the lunar surface until we really, really, really understand what the lunar surface is actually all about. That's why I enjoyed some of these previous talks here in particular, because I think that's a really useful tool and exercise in terms of better understanding what we're going to be working with. Resource management. So as I stated before, or as Izzy stated, I got my master's degree at the Colorado School of Mines in space resources. So I think understanding in particular, how can we do a really good job of managing those resources, balancing the interests, related to them. Also, sustainability and waste management, transportation networks. These are, things that we take for granted, I think, but in space, they are infinitely more challenging to figure out. In particular, I would say the waste management one. We actually had a podcast conversation about that with Nadia Khan from the MIT Media Lab. And it's just very interesting to think about at this point in time, how can we really support even just tens or maybe eventually hundreds of people living and working on the lunar surface? What are we going to do with the waste? How are we going to get those people around, right? So those transportation networks become very important very quickly. We want to be able to efficiently get around on the lunar surface to do science, to do, prospecting and whatever other kinds of work folks might be doing. And so that's going to be really key. And then one of the biggest things that I really feel very passionate about is expansion planning. So I think at this point in time, a lot of the feedback I get on the space urban planning side is that, well, we don't need to think about this yet because we're very far off from even, we're very far off from having a lunar city. Well, that may be true, but hopefully it's my feeling that we're not so far off from a future where we might have, even 50 people living and working on the lunar surface for periods of time. So how do we start to think about, planning for that natural expansion and making sure that it sort of goes in a systematic fashion? And then the question that was brought up in the chat just before this talk, but, of course, zoning, land use planning, not only for safety, but also for purposes of, are there heritage sites that we want to protect? Are there commercial, interests that we want to make sure, they're able to safely operate and other launches and landings might interfere with those, or just in general kind of find meaningful ways to kind of divide different uses and activities. So this next part, again, works a little bit better when we're all in person, but basically I really just like to show this slide to folks because I love figure ground drawings. I think they're probably one of my favorite aspects of urban planning. And when you look at these designs of what these cities with their patterns look like, right? I want everyone to sort of look at them and think about, okay, which of these places have I visited? And how did it feel when I was standing, in the, on the sidewalk, when I was driving around? How did it feel to me when I looked up, when I looked around? Did I feel, overwhelmed? Did I feel like I was a part of this, buzzing and smoothly humming environment? Were there challenges? Were there things that, bothered the senses? So I think understanding that the vibe and the culture and the efficiency and just the way that a city or a place can make you feel is inherently tied to its underlying design. I think that really paints the picture of why it's so important to be thinking about this now, and to be sort of laying that groundwork for what we feel might be a good way to get started on the lunar surface. And so oftentimes, I love to show this photo because I personally love it. I find it very interesting. I remember when I first saw this, and I think a lot of people are inspired by it. But I will also say that I think it is a real oversimplification of city planning. And I think SpaceX would be the first to admit that they haven't actually really put any thought behind what uses go where, or how it looks like they've created a grid pattern here, but it's just a lot of computer generated, obviously repetitive kind of designs here without a lot of thought behind it. So what I would like to see is, really a collective community visioning process where we are bringing together a group of stakeholders to start to actually vision out what this could be. And I think it's important when you look at these different examples, right? So we've got Barcelona here on the left, which is obviously one like very curated, strategically, designed city on the one hand. And then on the other hand, here we've got McMurdo Station. And I just think that when I look at McMurdo Station, I go, oh gosh, I just really hope that that's not what we do on the moon. Because you look at it and it's just a hodgepodge of buildings, and it doesn't really make a lot of sense. There's no ability for wayfinding. And there's not great sight lines or things like that. So there's lots of things to pick apart there. And not to pick on McMurdo Station because, I think that people didn't necessarily, perhaps at the beginning, anticipate that it would expand in the way that it did. But that's exactly my point, is that whenever I get that feedback of it's too soon to start talking about urban planning or city planning in a space context or on the moon, I would argue it's actually not, because if we want to create an efficient design that makes sense and can expand over time, we have to begin now, and we have to be thinking about it from a generational perspective. So one of the ways, and I know I'm really short on time, so I'm going to speed through these, but one of the ways that we can do this is through public participation. This is great for community building, consensus building, but also for minimizing cost overruns and delays and improving the decision or the quality of decision making. And so the reason why I bring that up, because if you think about how expensive it is to do anything in space, well, just think about how expensive it would be to undo something in space, right? So we don't want to be in that position. We don't want to have to be, fixing things or tearing down highways, so to speak. Obviously, we're not going to have highways, but the point is that cities terrestrially here have made a lot of expensive, poor decisions in terms of the way that they have laid out their cities. I mean, I'm in LA and driving around today for LA Tech Week. I am very much aware of how bad the transportation network is here. So it's something to think about, and I hope that people start to focus on that more. And then at Celestial Citizen, really, we aim to do this through a multi-channel approach. And so I won't go through all these different things in the essence of time, but basically, these are all the different approaches. We focus on thin participation methods, but also thick participation methods. So at the Humans to Mars Summit, we also hosted a workshop where it was a community-led analog habitat planning workshop, getting people's feedback about what that should look like. These sorts of things can be expanded to cover a wide variety of topics, and they really enable us to, to get some great early feedback as an industry. I'd like to see more and more groups and organizations doing this. I'd love to do this with NASA at some point on a topic. But there's a lot of different ways, and of course, also again going back to that dissemination of balanced information. That's something that we aim to do. And there's the whole slew of other tools that we can look to the urban planning community to for inspiration. And so again, I mentioned this before, but how we engage the public is through podcasts. We have Celestial Citizen and Continuum podcast. We have 2 newsletters. We also have 2 short films. You can find those on our YouTube channel. as I mentioned before, our virtual community now is 100,000 strong. So we have a lot of celestial citizens in our network now, and of course also through physical workshops and other events as well. And just to recap, really, it boils down to the future requires a plan. So, the key approaches that we, try to promote are real public participation, objectives, innovative policy making, cross-industry initiatives, systems thinking, tech integration, and we can be testing that out in really unique ways through analogs, community-driven visioning, consensus building, and development of norms. If you want to, you can join the conversation with us on Substack. That's also how our newsletters go out, so you can grab that QR. And then here's my contact information. I'd love to get in touch if anybody wants to talk further. Thank you so much for your time.
Awesome, thank you. Do we have one time for one question, and then we'll move on to the next one. So, how should mineral development, H2O, E3, be considered in making the lunar economy sustainable? Will mining towns be the point of the spear for development?
Yeah, I mean, that's a really interesting question. I think that ultimately, I think that the space resources conversation, I might be a little bit biased, but I think that that's going to be such a critical thing that we need to start to talk about and figure out in terms of how we're going to balance all the different interests. I mean, a big part of space resources, right, is that it's truly helping us live off the land in space. So it's going to be essential for us to use resources in space in order to be able to survive and expand longer term. That being said, to the point about mining towns, the one thing I will say, though, is we have to be very wary of company towns in space. Erica Nesvold actually just recently published an interesting newsletter article about this. And there's been some literature, not particular to space, but there has been a lot of literature in the urban planning community about company towns and sort of the hazards of that. And I think especially when you're in an extreme environment where just your safety and survival could be tied to the place you work for is a little problematic. So I don't know, that might be taking this question a different direction. But absolutely, we need to be thinking about space resources, how much we need to access to survive and sustain, a community of people. But then also, how can we be as lean in what we extract as possible? That's going to get complicated with corporate interests, of course. But I would proceed with caution there.
Absolutely, absolutely. And that's why we plan, is so that we don't end up with these monocultures and things that cause problems. So we got to plan for these things. So, and thank you so much. And next, right after Britt's talk at the Humans to Mars conference was Sam Simmons. He's a space architecture, and he was talking about building on the moon. And it was then that this idea was cemented. Pardon the pun. So we're going to go into building on the moon. And Sam Simmons is a space architect with over 30 years of experience in the aerospace industry with NASA, DoD, and international space programs. He is currently the CEO of Exploration Architecture Corporation, or XARC, and is a space architecture consulting firm that he founded in 2007. The firm specializes in commercial spaceport development, which I have one of my favorite is Houston Spaceport, and he does space systems development for space exploration initiatives and planetary surface systems for habitat and human settlement. So please help me welcome Sam Simmons.
Thank you, Izzy. Appreciate very much the invite here, and I will echo Britt's comment about the lineup here. It's a real good progression of topics and the way it works out. So today I'm going to talk about construction and how do we actually begin the process of building from the very first elements of the infrastructure. Let me get my charts up and then share the screen. get this in the presentation mode. So I guess we're good to go. All right. All right. So what I'm going to talk about is a subsidiary of XARC, a company we formed in 2020 called Astroport Space Technologies. And as Izzy mentioned, space architecture is the focus of the main company, XARC. You can consider them the architects, if you will, of our space plan and mission designs. But Astroport, as a subsidiary, is the civil engineering aspect of it. This is where we're looking at the materials development and the construction processes, the geotechnical engineering requirements, and the civil engineering processes that you need to understand to actually start building on the surface. And one of the first things you need to build when you go back to stay and decide you're going to build a camp or outpost or the beginnings of a settlement is the landing port, the Astroport. You know, where are you going to the point of entry for coming and going spacecraft or resupply missions and just entry into your settlement. So that's what we're focusing on, is the development of the landing ports. Now, I put this picture up here. I commissioned James Vaughn, the renowned space artist, to kind of, a little bit of a thought experiment. I wanted to kind of see what are we actually trying to get to, and what are some of these locations we might want to go and settle and develop. One, of course, is has always been mentioned, is the lava tubes, both on Mars and on the moon. And how would you actually begin the development of a lava tube settlement? This is just a notional, fanciful idea of we've been there for some time. This is probably way beyond the end of the century, and we're now exploring a new vein of tubes, from the settlement that had occurred as part of our living experiments in these lava tubes. So this is kind of like, we want to get to a place at some point in the future, and it's just way down the road here, where we actually are out of the cans, out of the spacesuits. We're breathing in pressurized, environments that are protected from the environment itself, and living in such a way where we can even bring our animals with us. There's a cat there in the bottom corner. Where are the animals going to come be part of our living environment? They've always been part of our heritage. And this settlement is doing things. It's a vibrant lunar economy. It's producing products and materials and gases and fuels or whatever, and for export or for use within its own confines. And it's such a way that it's here's a kind of the idea of what this how it would develop, where you live in both on the surface. There's as much surface activity and construction going on as there is underneath it in the lava tube itself. We've been working at a very particular place called the Marius Hills lunar pit, which is thought to be a lava tube at the bottom of the pit. And so we've been looking at how would that develop and evolve into this long-term settlement way into the future. And you see here a lot of activity going on. What's going on? Why are these people here? Why are they actually settled there? And why are we living here? And what's going on? So this is, if you look in the top, there's a little mining area over there on the right side of the screen where they're excavating, and they're going to need to use that regolith, which is contained with all kinds of minerals and gases, oxygen in particular, water for the fuels. They'll need to be doing a lot of the mining of the regolith to just generate the gas that they need to have to pressurize that environment. The hole itself takes 83,000 cubic meters of gas just to bring breathable air in there. And you need to have all these eclipse systems and a balanced economy, a balanced eclipse system. So there's a lot going on here, and we're way far from this. But we have like almost 100 years to get to this point in times in terms of technology development. So I think it's okay to kind of be fanciful here and figure out how it might look like in the future. And then this economy is also developed. It's probably even exporting the what they're mining up there, those of the regolith. They're actually taking the regolith topsoil and mining it for all those minerals and producing the fuels for export to for ongoing spacecraft to Mars or whatever. And maybe there's even the elements additional elements that are in the regolith, such as the titaniums and magnesiums and potassiums that could be used for export of a lunar regolith for construction materials for large array solar panels that are being beamed out. They're being constructed in low Earth orbit for powering the Earth. So this is the beginnings of this lunar economy, and then why we even think that it's viable that we can do settlement on the moon and make it a viable commercial venture. So I'll start this way. This is kind of where we want to be at. This is how we want to get to. But how do you begin all that? How do you begin this process? I'm going to show a video clip here. Hopefully it works. If it doesn't, we'll have to move on. Of kind of our process for the landing pad construction. Let's see if this is going to work or not. Are we good with sound?
Moon travel is
sound?
back,
All right.
and with it, opportunities for habitation on our nearest celestial body. Exploration Architecture Corporation, known as XARC, and our subsidiary, Astroport Space Technologies, are developing ways to enable people to settle on the moon and beyond. These new advancements could play an important role in bringing space exploration to the next level. Along with our research partners at the University of Texas at San Antonio, known as UTSA, Astroport has designed equipment that will convert raw material found on the moon into durable material that will be used to build lunar infrastructure. Here's how it will work. On the moon, there's a layer of loose, rocky material covering the bedrock. The bulk of the surface is a fine gray soil known as regolith, which is considered toxic to humans and machinery. It's abrasive and electrostatic, so it clings to spacesuits and gets in gears. And if it gets inside the habitation area, it is a health risk. But that soil also has a good side to it. Astroport has developed high-tech machinery that will ultimately use this regolith as building material to provide solid surfaces for roads or moon landings and takeoffs, accommodating a variety of spacecraft. The first step, create a process for turning the moon's surface material into brick. Researchers and scientists at UTSA are determining the exact temperatures needed to liquefy different combinations of moon soil to turn that melted material into extremely durable bricks. They're also conducting experiments on how much energy is required to melt the soil. Astroport and UTSA researchers have designed a tool called the Lunatron. It's an integrated induction furnace nozzle for forming and placing lunar regolith bricks for the landing pad construction. This machine gets feedstock from the surface, sifts it through a screen, heats it using an induction heating coil to melt the feedstock, then forms it into bricks and places it where it needs to go, all in one step. This technology is particularly groundbreaking, as there is no binding substance required to create the bricks or keep the tiles together once they're placed. Robots, known as brickbots, are deployed to assemble and place the bricks produced from the furnace nozzle into a reusable landing pad. To prepare the surface for the landing pad, an excavator and grader robot smooths over the landing site where the bricks are laid. Then a hauler robot takes the excavated regolith to the brickbot to be filtered and used as feedstock for making bricks. Once the landing pad is constructed, another regolith machine known as a RegoPack, short for Regolith Particle Acquisition and Containment, bags the regolith. It does this in a continuous manner to make long sandbags that are used to build the blast shield needed in case of explosions. When complete, the landing pad will provide a safe landing port that can be used to facilitate reliable and efficient space flights to the moon, Mars, and beyond.
So we're putting our money where our mouth is with all these pretty pictures, and we're actually able to work on the. Let's see, I can get out of the screen here. There we go. So we're actually building the melting the regolith. We in our labs we're been able to take the simulant and melt it into these hardened materials and solidify it into a durable solid surface. It's hard. It's stronger than high strength concrete. That's in the ambient condition where we're able to we melted in regular air environment. The challenge is getting into the vacuum chamber. You see there in the corners. where we can, how do we do that in the vacuum? So there's issues there with the outgassing of the simulant, and we've been able to do that. We had our first vacuum breakthrough this year, and or I'm sorry, in December of last year. And now we're trying to get, but it's not as durable, not as strong as the ambient bricks. So we're now working continually to improve that process and get the bricks to where we want them to be. We also are looking at our BrickBot. This is our technology demonstrator. We actually just received a notice of award, 2 additional SBIRs. That brick melting technology was done from last year's SBIR. Now we have additional ones here to do the integration of the furnace nozzle, which is in the corner there, into our robot, and then the conveyance of the razor drums that would be the scoopers to feed the BrickBot. This is not the Lunatron BrickBot that you saw in the video. This is our technology demonstrator that we want to put on Eclipse lander, hopefully by 2017 2027 to do a technology demonstration that we actually proof of concept. We can actually make bricks on the lunar surface. So in 2021, we began with the company idea. In 22, we received our first NASA STTR, did the melting technology. Just as I've just mentioned, we've got 2 more, actually 3 this year. The third one was for a surveyor bot, which is going up there and developing a robot that would be before you start doing the building and the construction, you have to survey the land. As Britt mentioned, that this is the site surveys. So the surveyor bot will go out there and do the ground truth of what's there for the particular site we're going to be at, and understand the geotechnics of the site, the bedrock depth, and all the things that go into basic civil engineering site surveying. A part of what we're doing is also doing the technology test beds, lunar improvement grounds here on Earth. We're located in San Antonio, at Port San Antonio. So the former Air Force base, it's still operational by the Air Force, but we're co-located there as a technology park on that base. And we'll be putting a lunar test bed for subscale testing of our robot and the terrestrial robot that we're going to try and develop here before we get to the flight hardware. Again, by 2027 is our goal to get on Eclipse lander and do the proof of concept with the demonstrating we can make 4 or 5 bricks there and just do the testing of the ability to what we end up producing. And then by the end of the decade, hopefully we'll be able to get operational with our Lunatron BrickBot system. I think it's probably more in the 2030 plus timeframe before we get there. So now that's the melting of the process and all that, the materials development piece of it. But let's go into one of the other STTRs we received was to do the site construction, the bulk regolith movement. How do you actually do the excavation, do the site preparation of the site? And we'd like to think of working this way with specific sites. Where's the actual site we're looking at, and not just generalized. Like in the case of the lava tube, we chose the Marias Hills lava tube skylight. Here we're looking at where the Artemis program is looking at from the South Pole. Some sites have been identified. We took a look at that, and we chose a location along the Gerlach Ridge area of the Shackleton crater, and started looking at what's involved with finding a flat spot the flattest spot we could find along that ridge, of course, with all the sunlight that we could get as well. And that turns out to be very challenging because just moving kilometers or even hundreds of meters away between a chosen location gives you different cuts and fills you need to do in terms of the site leveling, which is it's instrumental in terms of the bulk regolith that has to be moved. Here's some cartoons about what we're talking about in terms of the volume of regolith and bulk regolith that has to be excavated and moved and manipulated. You see on the top, in between the cones there of the piles of regolith, a 95th percentile male compared to the amount of regolith that would have to be used to just level a 100-meter diameter landing pad site. And so we're talking, huge volumes of regolith that has to be. It's just not a trivial task in terms of the machinery that has to be brought up there and how you design that machinery. That's got to be lightweight. We don't have the same sort of ability to have heavy machinery that uses its weight to be able to move and excavate the regolith, you got to deal with a lighter 1/6 gravity, and that means a different way of doing the excavation. Additionally, even your pad design on the leveling, you level out on the top surface, and then you do cut and fill. That gives you a different volume of regolith and bulk movements that you have to deal with. Or do you dig down to the bedrock or some depth? Now, maybe not all the way to bedrock because we don't know where it's at this point. But do you dig down and use that way to level your site for the pad itself? And both ways gives you a different volumetrics in terms of how much you have to deal with of that movement of all that regolith. You have to move the amount you need for the leveling of the site. You need another quantity for the feedstock that you would need for the pad itself, for the bricks. Another quantity that needs to be manipulated for the berm that would be used for the blast shield. And then we surface that with what we call a regol package. So you need another quantity for that. In this case, we're talking 30,000 cubic meters just by the leveling on the top. If you decide to go down and cut into it, do a cut and dig, you have almost 50,000 cubic meters of the manipulation of the regolith. But it turns out that this higher volume is more beneficial to us with our brick pop machine, because with the leveling by cut and fill, we still need to go somewhere else and excavate the amount we need for the bricks. In this case, we have the feedstock already being dug out for us, so we can use that for not only the filtering of the feedstock, but the regolith becomes a commodity to us as a commercial venture. We have our idea is to actually not only build and construct these, we want to operate these landing pads as well. So the commodity of all this regolith that we were digging out, what we don't filter out for the bricks still becomes very valuable for other applications, such as the beneficiations of the minerals and the gases that could be used for additional processes. So this becomes a more attractive application for us in terms of the leveling process by digging into it. And here's just some profiles of this particular site that we've chosen in terms of what has to be dealt with in terms of the cuts. You can see here in this picture, there's the blue dotted line there represents the amount that was cut out. You have to deal with in terms of geotechnics of the soil, the shear strength of it, the permeability and the fusivity, particle size, shape, and this down to the grain level. You have to understand the grain level interactions where you're at, and that helps with the design of the engineering design of the instruments, of the excavators and the sievers and the filters and the conveyance technologies. So there's a whole lot that we still don't know that we need to understand, which is why that surveyor bot that we're going to start developing is very important. Then you got to start looking about the layout itself. This goes into the beginnings of this urban planning that Britt was talking about. If this is going to be the beginning of your community, that's going to grow out. The organic growth is going to come from the layout of the landing site and the area itself. So you have the initial landing site up at the top. That's not going to be the place where you're going to be building a pad, because that landing site is the unimproved surface, the first landing, and you're going to offload from there all your equipment and move it to where you're going to actually build your landing site, because that rocket is a valuable commodity and we're talking about SpaceX in this case, because of the cargo, 100 metric tons of cargo it can hold. It's going to take off at some point. It's not going to stay there. So we have to get the equipment out of the way. We have to move it away from that second launch of the rocket, so it doesn't destroy the equipment. I think I didn't mention why we want the landing pads in the first place. The improved surfaces is because the plume blast that occurs when these landers land on the surface. All that plume blast is very energetic. It can sandblast and destroy all your placed assets. It can even go into orbit and circle around the moon, and it becomes problematic for incoming spacecraft. So that's the basic reason for the need for the improved surfaces. And so then you have the back to the landing pad area. You need an area for where when you offload your equipment, the first thing you got to do is set up your power system, your communication system, your charging station, before you can even begin all that excavation. And doing that setup, you got to cut roads. You got to cut roads to to where you're going to go for those power systems in that base station. Then you got to dig do the trenching and lay out the cable back to the charging station. All that has to occur before you begin the excavation piece of this process. And after that, then you just see that put in here. Okay, over on the right side, there's the longer road there, the double line. That's to the habitation area. So we're not doing that right now, but we just identified where the habitation area would be in relation to the landing site, and that's at a higher elevation because when we want to have it at a higher elevation because when you take off of that first beginnings of those rockets, you don't want that the plume blast raining down on the habitation area, essentially, because even though you have an improved surface, eventually there's still going to be micrometeorite and dust accumulated on the pad. You'll have to have sweepers at the same time. A bunch of equipment has to be put in place in there. So there's a whole complement of a CONOPS. What's the concept of operations for doing that construction? In relation to all the equipment you got to bring. There's a whole list of equipment that's associated with that process that we've just laid out in terms of the landing area. So that concept of operation gives you the timelines, how long it would take. If you can work within the diurnal cycles, we want to get as much sunlight as we can because we don't want to have to work in the lunar night. If we have to do that, that's a whole different design of engineering and complexity that goes into the machines. That's a lot different than if we had to just deal with the lunar daytime environment. So during the lunar night, we would do hibernation, and that would then it's a trade between that complexity of machinery versus the time length you would have if you were just working 2 weeks out of the cycle over lunar day and night. So those are essentially the overview of, I guess that's really, yeah. So here's the last one. The bottom line I'm trying to convey here is that it's going to be a swarm of robots, and it's not. A lot of times we see one robot making a construction and making a pad, but it's not. It's going to be a swarm of these things, and it's going to be very complex. We're going to be moving a lot of dirt. If you can just recall this slide here, there's much to learn here and much challenges ahead of us. And this is what Astroport is trying to tackle right now. And I think that's my last slide. Thank you.
Awesome. So we have let's do a question or two, and let's see. Okay, do you have an estimate on the amount of power needed to supply these robots for excavating and leveling, melting, and bricklaying?
Yeah, we're working that right now. This is our excavation study that we're doing for NASA. We're going to deliver that probably by August. I can tell you right now, it's in the megawatt range of power. This is the Achilles heels of any of this construction. Power is king. We're going to need nuclear power essentially to get what we need to have in terms of the ability to power these systems. And it'll be a combination of photovoltaics and nuclear power. In the initial stages, in our initial landings, we'll probably have to rely on the photovoltaics for doing the setup and that kind of thing. But eventually, we have to plan our I think we'll need to make sure we're in lockstep with the NASA kilowatt nuclear power program. But there's a number of programs I think NASA and the DOE is working on towards surface nuclear power that we want to make sure we insert into our timeline. So this available.
And another question is, do you anticipate the first lunar spaceport in cooperation with SpaceX Starship?
Well, so that the Starship is certainly the best application, the best transportation vehicle for us because of its cargo hold. It's 100 metric tons. We thought we could just bring one cargo hold of a Starship vehicle of equipment. But it's turning out that we're going to probably need more than that because of all the maybe two landers, but that impacts the whole CONOPS. We don't have a relationship with Starship right now. With SpaceX, will probably have to end up being that way at some point.
Well, awesome. So, thank you so much, Sam, for coming. I know that several of you had to rearrange your schedules in order to be here tonight, and I thoroughly appreciate it, as well as the audience, and a very sincere thank you for that. Now, why do we do all this? Why go to the moon? And one of the things I'd like you to consider is you've seen just just a smidge of the technology that goes into what we're looking at here, and all that technology that we discover as we reach for out of this atmosphere, it comes back down here, and we have to be sustainable up there. You know, we can't, it's too expensive to have excess waste. So we have to learn how to do it a better way. And all that technology comes back down here to make our time on Earth a better place. So again, thank you so much. And I'm going to open the screen here for anybody that would like to say a few words or talk about what it is that you're doing for your exploration into the moon, maybe a minute or two.
Yeah, I'll jump on. Daniels Hopkins with Grow Mars, looking to solve expanding loop systems that are scalable and sustainable in space. So that's what we're working on, and the history of human civilization has been kind of large scale productive agriculture or resource creation and extraction, and then cities. And then kind of infrastructure. So showing that pathway forward in a really extreme environment with very limited basic resources, I think has a lot of take home tech to on Earth. You know, wherever you are on Earth, you don't have to cut down the rainforest or invade a neighboring country over resources. You can do resource creation, you know, and expand as a population and as an economy. So that's what we're working on doing. And thank you for these additional pieces to the puzzle.
Awesome. Thank you. Thank you. Anybody else want to say a few words? Hi, John, you're on mute.
Yeah. First off, this is a great program, Izzy. Thank you very much. Learned some stuff, and it's always great to see what people are working on. One area that I don't think was mentioned, which I think is a very key driver both for the moon and Mars, is issues related to radiation. Cosmic radiation, solar flares. The work we've done is mostly dealing with underground for protection, particularly for long-term habitation. Does anyone have a minute or two to talk about radiation issues?
I was just going to say that, yeah, John, you're absolutely right. I mean, like the human health and safety part of this, I feel like there's a lot of hand waving, right, that we're doing as we talk about all of this. And I mean, you know, I think that as we consider habitat design, even, you know, whether or not initially, I mean, personally, I'm in the camp of the lunar surface. I know that there's a lot of folks that are also interested in potentially, you know, seeing if it's possible to live in lunar lava tubes and things like that as well. But, you know, I think either way, we're going to have to obviously really focus on the materials used, the design of the structures that we live in space and things like that. And I don't proclaim to be an expert in material science or radiation, so I'm not even going to try to act like it. But I will say that, you know, it's absolutely something that we need to be thinking about, you know, because there's really no easy answer for that. And as we look to have people on the surface, it's also a big question of like, how long can we leave them there, right? Like, what is actually the safe amount of time in 5 years, in 10 years, you know, and then how can we continue to work on kind of that component of figuring out radiation shielding that hopefully gets more innovative and progressive over time so that it can start to match the progress we're making otherwise. But thank you so much, everyone. Really enjoyed the presentations, and I appreciate the attentiveness. So thank you, Izzy, for organizing.
Well, thank you for coming. And again, I love what you're doing. And with that, I think we're going to call it a night. And thank you again, Sam. And like I said, I know that you had to rearrange your schedule to be here, and I do sincerely appreciate it. And
Thank you.
With that, we will call it a night. And thank you for a great Space for Kentucky, which is more space for everyone.